Welcome to this video lecture. My topic is to prove that line-to-line voltage is equal to square root of 3 line-to-neutral voltage with an angle of 30 degrees. In this equation, the line-to-line voltage is leading the line-to-neutral voltage by an angle of 30 degrees. And line-to-line voltage is bigger by square root of 3. Suppose we have a 3-phase Y-connected load supplied by 3-phase Y-connected source. If we are going to trace the circuit between line A and line B of the source, we can say that line voltage VAB is equal to VAN plus VNB. This equation can be represented by means of phasor diagram. So we have phase voltage VAN, VBN, and BCN. And they have a displacement angle of 120 degrees. So this is the phase voltage BNB. As per equation, we will see in this diagram that BAN plus BNB is equal to BAB. If we draw a vector opposite to phase voltage BBN or 180 degrees out of phase with BBN, we can call this as negative BBN. So we can replace phase voltage BNB by negative BBN. So therefore, the new equation will become BAB is equal to BAN minus BBN. Looking in the phasor diagram, how can the line voltage VAB can be expressed in terms of phase voltage BAN? We will notice that the vectors BAN, negative BBN, and BAB creates an obtuse triangle wherein it is difficult to solve the magnitude of the vectors. So let's try to manipulate the phasor diagram by drawing a perpendicular line from the midpoint of voltage VAB up to the endpoint of voltage BAN. So we will draw a perpendicular line from the midpoint of base voltage VAB. In that case, it will create an identical right triangle. We can say that this side is 1/2 BAB. And we have an angle of 30 degrees. How can we be sure that this angle is 30 degrees? We can see that the angle between base voltage BAN and BBN is 120 degrees. BBN is 30 degrees from negative y-axis. And therefore, the opposite angle is also 30 degrees. So the angle between BAN and negative BBN is 60 degrees. Since this is a parallelogram wherein the opposite sides are all equal, if we draw a diagonal line, we can be sure that it will create an identical obtuse triangle with 30 degrees angle. Looking again in the diagram, we can say that cosine 30 degrees is equal to 1/2 BAB over BAN. Cross multiplication, we get cross multiplication again, we get and what is the value of cosine 30 degrees? Cosine 30 degrees is equal to square root of 3 over 2. So therefore BAB will become therefore 2 is cancelled. If we look from the phasor diagram, we can say that BAB leads BAN by 30 degrees. Therefore, BAB will become in this equation, the line-to-line voltage is leading the line to neutral voltage by an angle of 30 degrees and larger by square root of 3. Since this is the end of my lecture regarding the derivation from line-to-line voltage to line-to-neutral voltage, as a bonus information, I am going to prove that cosine 30 degrees is equal to square root of 3 over 2. Suppose we have a coordinate plane and we have a circle with radius of 1 and the center of the circle coincides with the 0, 0 vertex of x and y axis. This point has x and y coordinates. Now we have a right triangle with 30 degrees angle. We do not know the length of the opposite and the adjacent sides. Now if I draw a similar triangle below the original triangle, which is also 30 degrees angle. This is also 1. And since we know the radius is 1, and since this triangle is an equilateral triangle, we can say that this side is also 1. So this half of 1 is 1 half. So the angle will become and this is unknown. Now to solve the adjacent sides, we will use the Pythagorean theorem, wherein c square is equal to a square plus b square. So this is a, this is b, and this is c. Solving for b, we get b square is equal to c square minus a square. Therefore, b square is equal to 3/4. Therefore, b is equal to square root of 3 over 2. And that's the end of my lectures. Thank you very much.